Hi friends, good morning. I am Dr.M.H.Annaiah, Professor of Mechanical Engineering and Vice Principal at Saptagiri College of Engineering, Bangalore. I welcome you all to the session on the projection of pentagonal pyramids. Before I take up the actual problem on this pentagonal pyramid, let me show you the model of a pentagonal pyramid and explain the nomenclature of the same. So as the name indicates, a pentagonal pyramid will have a pentagonal face, that is 5 sides and 5 corners will be there. The center of these are marked as O1, and O represents the apex of the solid. The imaginary line connecting O, the vertex, and the base of the solid is called the axis of the solid. So for a pyramid, you will have a base, and all the base corners are connected to the vertex by number of lines called slant edges. For example, for this pentagonal pyramid, we have 5 points in the base. It has got 5 sides, A, B, C, D and E. And all these 5 corners are connected to the vertex by slant edges OA, OB, OC, OD and OE. So in today's problem, I am going to have a pentagonal pyramid which is base, it has got a base of 25 mm, which is going to rest on one of its base edges. So friends, I will show you this. This is a pentagonal pyramid, and there are sides, 5 sides are there as I told you before. Now the problem runs like this. A pentagonal pyramid of side of base 25 mm and axis 50 mm long rests on HP on a side of the base. So let us analyze the problem step by step. We have a pentagonal pyramid. This indicates a pentagonal pyramid. It has to rest on a side of the base. So as per the rule I have taught you in the previous sessions, one of the side of the base should come to the right side of the observers, and it should be normal to the VP, the vertical plane, when you place it on HP. So what I do now is, I place the pyramid on its base on HP such that the side AB of the base is normal to VP and it comes to the right side of the observers, obtain its top view and the front view. Friends, you know very well, whenever any of these pyramids are placed on HP, the true shape of the base can be seen from the top view. So when I place the pyramid on HP, on its base, I will be able to see the complete base of the solid, that is A, B, BC, CD, DE and EA. You can also observe this vertex O, and all these corners of the base are connected to this by number of slant edges OA, OB, OC, etc. Now to start with, I am going to place the pyramid on HP such that one of the base edges of the solid is to the right side of the observer, get its top view. So top view is going to be a pentagon. Now let me mark a line, the XY line, mark X and Y, the line of intersection of VP and HP, and to indicate the first angle projection, I mark VP by HP. It indicates first angle projection. Now, I told you when you place the object, the pyramid on HP, one of the side or base edge of the solid should come to the right side of the observers. Now, I am going to construct a pentagon here. A pentagon, there is a figure having 5 sides, on each side measuring 25 mm. So this is 25 mm, 25 mm. So this is a pentagon. I mark it as A, B, C, D and E. After getting these sides, I just mark the dimension of one of these sides. So you can just mark 2 lines and say this is 25 mm each. Then after getting the top view of the base, I have to locate the vertex of the solid, that is O. So that can be got by just writing or dividing these two adjacent sides. If I just divide this AB into two equal parts or bisect it, you get a point here. Similarly bisect this side BC, the point of intersection of these two will give you O, the center of the base. So I call it as O, the top view of the front view of the vertex, and O1, the center of the base. And as I've shown you before, the vertex of the solid is to be joined to all the corners. That is, I have to join O to A, O to B, O to C, O to D, and O to E. So I show all these lamp generators by visible lines. This is OE, OD will be horizontal, OC and OB. I have got the top view of the solid. Now I should get the front view of the solid. So let me get these points one by one. So to start with, let me mark the axis of the solid. From O, I write a vertical line representing the axis and mark the vertex as O dash at a height of, the height of the solid is given to be 50 mm. So I mark 50 mm. The center of the base of the solid is O1 dash. Then get all these points one by one. So A and B fall on this line. So this will represent A dash, B dash, one of the edges. Then C and E will come together. They fall on the same point. That is C dash, E dash. The last line is D. Get this on the XY line. This is your D dash. So if you just join this point from D dash to A dash, B dash, this represents the base of the solid. So now I have to join the vertex to all these corners. So I will be joining O dash, B dash, one of the slant edges, OC and OE will come here, O dash, A dash and O dash, B dash are the other two slant edges. Friends, if you observe now, the last line O dash, A dash, B dash represents one of the triangular surfaces of the solid, and this O dash, O1 dash is the axis of the solid which is perpendicular to HP. Perpendicular to HP. What is that in the problem? He says, draw the projections of the pyramid when the axis is inclined at 40 degrees to HP. Right. Here the axis is perpendicular to HP. Now I have to redraw this figure such that O dash, O1 dash gets inclined at an angle of 40 degrees to XY. So the same figure has to be redrawn here. We will call this figure as number 1, and 1 is to be redrawn again. So I am going to take some point here, A dash, B dash, anywhere on this XY line, and mark that length equal to A dash, B dash, D dash. So the uppermost point at the left is that D dash, bottom point is A dash, B dash, this is A dash, B dash. Then construct this complete figure. So if I complete this figure, it will be something like this. Let me mark all these points. How to locate this CE? Measure this distance and mark off here. So this is going to be C dash and then E dash. Then you have the axis which will be perpendicular to this. This is O dash and this is O1 dash. Finally A dash, B dash. So here he says that the axis is at an angle of 40 degrees to HP. So how do we construct this figure? Take some point A dash, B dash at random on XY. Mark this base A dash, B dash, D dash of length equal to the length obtained from the front view of figure number 1. I just draw that. I know the height of the solid. The height of the solid is known to be 50 mm. So this I take it as 50 mm. Then you know how to construct this triangle when all the three sides are known. So I am going to join all these lines. So whatever the figure you have got here is redrawn with the axis O dash O1 dash inclined at 40 degrees to HP. I call this figure as number 2. Friends, you should know that both figure number 1 and 2, they are identical in all respect, and one should be very careful in marking these edges or corners of the base. By mistake, instead of writing this D dash here, if you replace D dash and A dash, B dash, the complete solution becomes wrong. So one should be extremely careful while numbering and naming these corners of the solid. Friends, we have the initial position with the axis at 90 degrees to HP, that is redrawn here, same figure, redrawn here at an angle of 40 degrees. Now let me get all the 5 corners of the base starting from the side AB. So to get that, the procedure we follow is draw a vertical line from A horizontal line from here. The point of intersection of these two lines will give you A. Likewise, obtain B. Vertical line from B, the horizontal line from B. This point is B. Likewise, you get C and E. So C and E, E will fall on this. This is your E, and C will be somewhere here. This point is C. Then finally D we want vertical line. Draw a vertical line from D, a horizontal line from D. The point of intersection of these two will give you the corner D. Then finally we have the vertex. Vertical line from the vertex, horizontal line from the vertex, which will pass through this D, and you have this point O. Friends, you got all the 5 corners of the base A, B, C, D, E, and also the vertex O of the solid. Likewise, let us also mark this center of the base, that is O1. Draw a vertical line from there, a horizontal line from here. This will be your O1. So we have got all the points. 5 points for the base and 1 for the vertex, 1 for the base. So let me join. Let's see. I told you, as per the rule, all the outlines, the border lines of the solid are visible. So which are they? I can join this A to E, full line, E to D, full line, E to C, full line, then this B to C, full line, A, B, C, D, E we have got. Now when you observe from the top, friends, since the object is resting on the side AB, so it was something like this, we have drawn like this, the position now. The object is resting on AB, one of the edges of the base. But when you view from the top, that edge AB is not visible to the observer. Hence, I show this by a dotted line. So that means it is an invisible edge. Again, when you see from the top, look here, you will be able to see this slant edge. That slant edge at the top is O dash D dash. Hence, I am going to join the slant edge OD in the top view by a full line visible. Next, O to A. Look here, this O to A, O to B. Let's see how they will be. So, when you are having joined this O to E, this O to E is visible, a full line. O to C is also visible, a full line. So only this is dotted. OA is visible, OB is visible. So friends, you can see that the object is resting on the side AB on HP, which is not visible in the top view, whereas this slant edges OA, OE, OD, OC, OB all are visible excepting AB, the edge on which the solid is resting. And you can also observe here that the axis of the solid represented by O1 is here, O1 is here, and this axis of the solid, you can say it is parallel to VP. So friends, you have drawn two positions. Once again, a brief note about this. The solid was placed on HP on one of the base to start with, got the front view and top view, then it was redrawn with the axis making 40 degrees with HP, and we obtained the corresponding top view. Now the axis of the solid is parallel to VP. In the question he is asking, draw the projections when the top view of the axis is inclined at 30 degrees to VP. So whatever the figure is here, where the axis of the solid is parallel to VP, is to be redrawn such that O1 is inclined at an angle of 30 degrees to VP. So I have to redraw this figure here and finally obtain the front view of the solid. To do that, I am going to draw a line here, at an angle of 30 degrees to VP. Suppose this is the line I am drawing at an angle of 30 degrees on which I am going to reconstruct this figure. Let's see how to construct that. So friends, you know this, you can mark O somewhere here, anywhere on that line. This is O. The last point on that is D. So OD, you take this line and mark that OD here. Say this is our OD. The point is D. You simply take this distance and mark off on this. Then from there, just start marking other corners. We got O, we got D. Then I should mark C and E. Take this much of distance on that line OD and obtain this E and C. So I mark the distance, write these two lines. This length is equal to OE and this is this distance. They are same. So I will say one end of that is E, other end is C. You can mark anywhere. So this will be C, say. This will be E. You know how to mark that. Then move on that line and obtain this A and B. Mark this gap from this line, means from the C line you mark this gap and locate A and B. So I mark this distance and mark that AB. Mark that AB. So this is ABCDE. This should be A, and this is B, C, D, E. I have got all the 5 corners of the pentagon. Then I have located this also. So whatever the lines are joined here, follow the same procedure and get all these. So I am going to join C to D, D to E, A to E, B to C, then O is to be joined to C, O is to be joined to B, then O to A, O to B. Then here, this AB is a dotted line. So I will show it by an invisible line. Then locate this O1 also from D. O1 comes well within that AB. So I will mark this as O1. O1 is the center of the base. Friends, whatever the figure I have drawn here is exactly the photocopy of this figure. I will call this as figure number 3 and this figure as figure number 4. That is to say, figure 3 and 4 are exactly identical. After getting this, finally I should view the object from this end and get the final front view of the solid. So follow the procedure. Start from the point A. So let me start from point A. A is here. Draw a vertical line from A, a horizontal line from here. You will get the point A dash. Likewise B, vertical line from B, horizontal line from B. The point where those two intersect is B. We will call it as B dash. Then C and E, horizontal from C, vertical line from C, The point of intersection of these two is C dash. So all this will come in an order. Likewise, we have E, vertical line from E, horizontal line from E. It will be somewhere here, or here to say specifically. So this is your E dash, because they have to follow the same line. Then you got A, B, C, E, D I should get. Vertical line from D, horizontal line from D. So D is somewhere here, a vertical line from here. Yes, vertical line, horizontal line. Finally the vertex, vertical line from O, the horizontal line. The point of intersection will give you O dash, the vertex of the solid. Friends, I told you, this is point D dash, B dash. Okay, you know very well that when the object is viewed from the base side, the complete base of the solid is visible. So all these 5 corners of the base are to be joined by full lines. So A to B, B to C. So after getting all these points, they have to be joined. The complete base of the solid is visible to the observer. Hence, all the 5 corners of the base, A dash, B dash, C dash, D dash and E dash are visible. They have to be joined by full lines. Now coming to the slant edges, join O dash to A dash, full line, O dash to E dash, full line, O dash to D, full line, O dash to B dash. When you joining O dash and B dash, it is intersecting the edge E dash, A dash. So this has to be a dotted line. Likewise, when you are joining O dash to C dash, this is also going to be an invisible line because it is intersecting the side A dash, A dash. Finally, obtain O1, that is a horizontal line from here, a vertical line from here. This becomes your O1 dash. Show it as axis dash dot dash dot dash dot. Friends, you can see now that the object is resting on one of the base edges AB of the solid, and the complete base of the solid is visible. And if you want to just check whether the answer you got is right or wrong, you can have a verification. Now the axis of solid in the first position was perpendicular. It was redrawn at 40 degrees to HP. We got the top view. In the top view, the top view of the axis is parallel to BP. He says it has to get an angle of 30 degrees to BP. Hence, I have redrawn this figure 3 as 4 with that axis O1 at an angle of 30 degrees to BP, and have got the front view of the solid where the complete base of the solid is visible. The invisible slant edges O dash C dash and O dash B dash are shown by dotted line. This gives you the complete solution. This is our front view, which you mark as FP, and this is the top view. Friends, this is a complete solution for the problem, and if you find and if you feel that this amount of knowledge is useful to you, you please share this link with your other friend so that it is going to be of use to them. Thank you. This is Dr.M.H.Annaiah signing off.